Hello students, we will first see here the solved answer of the homework questions given to you on the last class. So first is the differentiate between mixtures and compounds. So there I told you to write at least 4 differences between mixtures and compounds. So first is it is made up of 2 or more pure substances mixed in any proportion. Example, sugar solution and other also. So here in mixture you have pure substances, 2 or more pure substances just mixed in any proportion. That is, in mixture you have different variable proportion of the substances. Example is sugar solution. Second, here in compounds it is a pure substance made up of 2 or more elements combined together in a fixed proportion. This is the difference. Here 2 or more elements are combining in a fixed proportion. It means proportion is fixed between the 2 or more combining elements. So this gives rise to a compound. Example, water, carbon dioxide and many more. Okay. Second is because we are going to mix or we are mixing 2 or more pure substances. So no new substance is formed. And here in compounds we are combining the elements in fixed proportions. So there is a formation of new compound. Third is a mixture show properties of its constituent substances. Whatever the pure substances are mixed with each other, they will show individually their physical and chemical properties. Okay, whereas a new substances has totally different properties. So when we get the new substance, a compound, it has its specific properties than its individual constituent substances. Okay. Fourth is its constituent can be separated easily by physical methods. You have mixtures can be separated by several physical methods that we have studied. Okay, so one or more mixtures can be separated by physical methods. Now, its constituents cannot be separated by physical methods. So, the constituent particles or constituent substances of compounds cannot be separated by any physical methods. So, you have to go for any chemical or electrochemical reaction. Simplest example is the electrolysis of water, by which you can just separate hydrogen and water. Okay, and there are several chemical reactions also, so which will help us to separate the constituent substances of compound. Okay, now second is explain the following by giving examples. So here you have 3 or 4 terms. Here you have to define it, explain it little along with the examples. First we'll see saturated solution. When no more solute can be dissolved in solution at a given temperature, it is called saturated solution. Okay. Example, when no more sugar particles can be dissolved in water. Okay. So if we see that we have added enough sugar solution and no sugar particles and no more sugar crystals or particles are able to dissolve in the water, then we get the saturated sugar solution. Okay, now pure substance, it is a single form of matter consisting of single type of particles, and these constituent particles are same in their chemical nature and cannot be separated by any physical processes. So whatever the elements and compounds are there, they are all pure substances. Example, iron, it is an element. NaOH, sodium hydroxide, it is a compound. So they all are pure substances. Now colloid or colloidal solution, it is a heterogeneous mixture whose particles are uniformly spread throughout the solution, and due to relatively smaller size of particles, the mixture appear to be homogeneous, but it is a heterogeneous mixture as the particle easily scatter beam of light and hence show Tyndall effect. The colloidal solutions, they look like solution only because particle size are smaller as compared to the normal heterogeneous mixture, that is suspension. But if you pass the light through the solution, colloidal solution, they will scatter the beam of light. That means they show the Tyndall effect. So with that we can just confirm it is a colloidal solution or not. So examples are milk, fog, smoke, etc. Now you have one more term, suspension. It is also a heterogeneous mixture in which solute-like particles do not dissolve but remain suspended throughout the bulk of medium, and here particles of suspension are generally visible to the naked eyes. Here the suspended particles are very much visible through our naked eyes, and examples you can give here: sand, water, oil, water, etc. Now you have classify each of the following as homogeneous and heterogeneous mixture. So homogeneous mixture, all the solution come under homogeneous mixture, like soda water, air, vinegar, filtered tea, they all are solution. So all the solution come under homogeneous mixture. Now heterogeneous mixtures are wood, soil, sulfur and carbon disulfide. So there was confusion in sulfur and disulfide whether it is a solution or it is a heterogeneous mixture. So it is actually a heterogeneous mixture, because though we get a clear yellow solution by dissolving sulfur in carbon disulfide, but when we pass the light through this solution, it shows the Tyndall effect. That will confirm it is not a solution, actually it is a colloid, because here the sulfur seems like it is completely dissolved in a carbon disulfide solvent to give a clear yellow solution, but it is not like that. Here the particles of sulfur are actually spread uniformly throughout the carbon disulfide solvent. So it is actually a colloid. So colloid come under heterogeneous mixture only. Would also have different constituent substances which are ununiformly mixed throughout it. So throughout the mixture, so it is also categorized under heterogeneous mixture only. Now soil also, you can see several distinct particles present in soil, and they are not uniformly mixed also, so they are also heterogeneous mixture only. Now next question is, how do you confirm that a colorless liquid given to you is a pure water? So we know that pure water has its fixed melting and boiling point, we know. Hence, if the given colorless liquid is pure water, then it must boil sharp at 100 degrees Celsius and also should freeze sharp at 0 degrees Celsius. Okay. So that if it boils at 100 degrees Celsius and freeze at 0 degrees Celsius, which is the melting and boiling point of pure water, then we will come to know or confirms that whatever the given colorless liquid is a pure substance. However, if the colorless liquid boils above or below 100 degrees Celsius, then it is the liquid which contains some dissolved impurities in it. Okay. Now next is pick pure substances from the following. So in pure substances you have to see elements and compounds are there, means they all come under pure substances. Ice, water, water is a compound, iron is an element, HCl, hydrochloric acid is a compound, calcium oxide is a compound, Hg, mercury is an element. So they all come under pure substances. Mixtures are milk, milk is a colloid, it is a heterogeneous mixture. Then brick also is made up of many constituent particle substances which are ununiformly mixed, so they are heterogeneous mixture. Then wood also, as I told you, it is also heterogeneous mixture. Air is a solution, it is a homogeneous mixture. Now identify solution from the following mixture. So in solution you have sea water, air, soda water. Then heterogeneous mixture you have sea water, soil and coal. Why sea water is categorized under both homogeneous and heterogeneous mixture, I'll just explain you in today's class only. So that was about your homework questions. If you have anything to correct, just do it. Now we will see some NCERT based questions. So this is actually the exercises class going on of second chapter. Okay, So we will see one by one here. First question is, which of the following will show Tyndall effect? So you people know that Tyndall effect is only observed in the heterogeneous mixture, especially in the colloidal solution. So we will see salt solution. Salt solution is what? It is a homogeneous mixture. So here we will not see Tyndall effect. Now in milk you know it is what? It is a heterogeneous mixture, and in that also it is a colloid. So we will see here, we will see the Tyndall effect. So here we can write just yes. Okay. Now third is copper sulfate solution. So copper sulfate, when you add copper sulfate in water, it will give you a homogeneous solution. So in homogeneous solution you will not observe any Tyndall effect. So we will write no here again. Now starch solution, when you add starch and to make a solution and in a suitable solvent in water, and you can see in starch solution you can see it is actually a starch getting spread in the solvent itself. So it is actually a colloidal solution. So here we will see the Tyndall effect. Okay, so we saw Tyndall effect in milk, and we will see Tyndall effect in starch solution also. Okay, now second is, classify the following into elements, compounds and mixture. So we will see one by one. Sodium, you know the symbol of sodium is Na. It is an element. So we will write it is an element. Soil is what? It is a mixture of several things in it. So it is a mixture. That too, it is a heterogeneous mixture. Sugar solution, you know it is a homogeneous mixture. Means it is a mixture. We have to classify this whatever are given into element, compounds and mixture. Okay. Silver is a metal. It is an element. Symbol of silver is Ag. So we will write here element. In element also it is what? A metal. Okay. Sodium also element and it is a metal. Calcium carbonate, CaCO3. So it is a compound. Okay. Now you have tin. Symbol of tin is Sn. Okay, capital S, small n. So tin is also an element. It is also a transition metal. Now silicon is what? It is also an element. Which element? Which type of element it is? Silicon is a metalloid. Okay, you have studied now? Okay. Then coal is a mixture of various things in addition to carbon and all. It contains sulfur, nitrogen, various gases and other things also mixed in it. So it is a mixture. That is, it is a heterogeneous mixture. Okay, now air, you know it is a solid solution. It is a homogeneous mixture, still a mixture only. So we will write mixture. Soap is actually a sodium and potassium salts of higher fatty acids. So it is some of its constituents are very much fixed, are in fixed proportion, but some of the things are not fixed. It also contains soap, also contains glycerine and some other medicinal constituents also. So we cannot categorize soap as compound, so we will write it as mixture only. Okay. Now methane. Methane is what? So it will be a homogeneous mixture. Okay. Methane formula of methane is CH4. It is made up of 1 atom of carbon combining with 4 atoms of hydrogen. So methane is a compound. Okay. It is made by combining 1 atom of carbon with 4 atoms of hydrogen. Okay. Now carbon dioxide is also a compound, you know, because here the elements combined here are in fixed ratio. Okay. Now blood you know it is a colloid solution, so colloid solution come under mixture only, heterogeneous mixture, so it is a mixture only. Okay, the next one is, which of the following are chemical changes? So growth of plants, you can see growth of plants, many biochemical processes, metabolic processes are taking place. So growth of plant is chemical change. It is also a physical change. You can see there is irreversible physical change. Okay, there is increase or enlargement of height, weight and all. Okay, now rusting of iron is totally a chemical change, because iron is getting formed into iron oxide. Okay, so it is a chemical change. Mixing of iron filling and sand, if you just add some iron fillings, that is iron powder, in sand, that means you are just doing the mixing process, so it is a mixture going to form, so it is not at all a chemical change, it is a just a physical change only. Okay, now cooking of food, during cooking of food, many chemical changes you can see there, because here food are getting burnt, and during burning or heating, when you heat anything, when you burn anything, you'll get to form a new substance. So new substance formation means what? A chemical change is happening, so it is a chemical change. Now digestion of food, so in digestion of food, chemical processes is taking place where your food is getting broken down in the presence of oxygen and give rise to various new things, energy and various new things. So here digestion of food is totally a chemical change only. Okay, then freezing of water, you are just making a liquid water into ice, so it is just a physical change. You can get back again ice into water, so it is just a physical change, there is no chemical change happening. Burning of candle is both physical and chemical change, so we have to just denote what is chemical and physical change happening. So we will write here chemical change is happening here. As you know, during burning of candle, what is happening? First the wax solid is getting melted, that is a physical change, and during melting the heating of wax also is taking place, where actually the chemical change is taking place, where the wax is getting vaporized and it is getting converted into carbon dioxide, carbon monoxide and various other smoke, soot and other gases. So here chemical change is happening. Okay, now you have fourth question. Sea water is classified both as homogeneous and heterogeneous mixture. As I told you, some of you have written sea water is a homogeneous mixture and some of you have written as heterogeneous mixture. So sea water is categorized under both homogeneous and heterogeneous mixture. This is because I'll have given you the explanation. If we just consider the sea water containing salt, water and some other dissolved gases mixed uniformly throughout to form a solution, seawater solution, then seawater is a homogeneous mixture. But actually we know that seawater does not only contain salt, water and some dissolved gases, but it also contains mixture of dirt, mud, decayed plants and animals and several other things in addition to salt, water and gases. So we cannot categorize seawater as homogeneous. So we have to categorize seawater in heterogeneous mixture only. So there is confusion between homogeneous and heterogeneous mixture. So in some books it is written homogeneous, in some book it is written heterogeneous mixture. So we will categorize it under both homogeneous and heterogeneous mixture. Okay, so I have given you the separate explanation why it is called so. Okay, the next question is a saturated solution of potassium chloride, that is KCl, prepared at 60 degrees Celsius is allowed to cool down at room temperature. What would you observe? So you have been given potassium chloride, saturated solution of potassium chloride, which is prepared actually at 60 degrees Celsius, means by heating we have prepared the saturated solution of potassium chloride. Now it is said that it is allowed to cool down at room temperature. What is going to happen then? Formation of crystals of potassium chloride is observed on cooling. Okay, very simple question. Okay, second is, an aqueous sugar solution is heated to dryness. What would you observe? Now, what do you mean by aqueous? Aqueous means containing water. Means sugar solution is made by adding sugar into water. That means aqueous solution of sugar solution. Okay, so aqueous sugar solution means sugar solution in water is heated to dryness. Okay, what would you observe? Heated to dryness means what? Evaporation takes place, leaving behind sugar in the container. Okay, but what happens? Here the sugar may be charred or burnt due to more heating. As I told you before also, during evaporation there is unevenly heating. So due to more heat or excessive heat, whatever the sugar is remained can be charred or burnt. Okay. The next question is, a mixture of iron fillings, that is iron powder, and sulfur powder heated together. Okay, what would you observe? So when anything is getting heated, that means chemical reaction is going to take place there, going to be taken place. Okay, so if we have, so we will do the chemical reaction here. So mixture of iron filling and sulfur powder are heated together. Okay, so you have iron filling, that means iron. Obviously it is in solid state, so in coast we will write solid. Iron in solid state. Reacting means you have to put the sign plus here. This means it is reacting with something. It is reacting with what? It is getting mixed with, or it is getting heated with what? Sulfur powder. So this is the symbol of sulfur. It is also in solid state, so we will write solid here. Okay, now these both are getting heated. So what is the sign of heating? You can have a triangle sign. That means what? It is, these two are getting heated. So on heating we will get FeS, a brownish black stone like substance, that is ferrous sulfide, and it is also in solid state, so we will write S here. What is this? It is ferrous sulfide, brownish black, okay, stone type. Okay, so if question is asked like that, you have to show like this. Okay, the next question is, why particles of colloidal solution do not settle down when left undisturbed, while in case of suspension they do? We see that if you keep the colloidal solution undisturbed for a long time also, you will not see any constituent particles getting settled down at the bottom. But in suspension it is like that. In suspension, if you like sand water, so if you just keep that suspension thing undisturbed for some time, you can see all the sand particles get settled down at the bottom. Why it is so? Why it is not happening in colloidal solution? So answer is, the particles in colloid are in contact continuous or constant motion. Okay, they are moving continuously in the solvent like substance. Okay, so it has a strong intermolecular force of attraction between the particles. Whatever the particles which are there in the colloid, which are just spread throughout in the colloidal solution, are in continuous motion, and they have a strong intermolecular force of attraction between each particles. But particles in suspension are bigger, as you know, than that of colloid, and also the intermolecular forces between the suspended particles are not stronger to keep the particles suspended, still spread or continued moving or continuous moving in the space of the colloidal solution or suspended solution. So what happens is here, because the intermolecular forces between the particles of suspended particles are not stronger, hence they just settle down at the bottom slowly. Okay, so this is the reason why the particles of colloidal solution do not settle down, because particles of colloidal solution are in constant motion. They keep moving in the space of colloidal solution. Okay, and also they have a strong intermolecular force of attraction between the particles. That is why they will be in the space of the colloidal solution only. They will not settle down at the bottom. Okay. Ninth is, when the name the processes associated with the following. So you have to write the what process can happen is happening here actually. Okay, first is dry ice is kept at room temperature and at 1 atmospheric pressure. As you know, when you keep the dry ice open just like that, then what will happen? Which process is going to take place there? Sublimation. Soon dry ice will vaporize from solid to just gas. It converts into solid to gas. Dry ice will soon vaporize. Okay, so sublimation process will take place. Second, a drop of ink placed in the surface of water. If you just drop some ink on the surface of water, what is going to happen? Which process? Diffusion. All the particles of ink get into the space of the particles between the water molecules. Okay, so you can see the diffusion process will take place. A KMnO4 crystal, that is potassium chloride crystals, they are pink in color, they are added to a beaker containing water. What is happening here? What will happen here also? First is dissolution. Dissolution process takes place. Dissolution process as well as diffusion process also. Color will spread throughout the solution in water. They will make a pink solution. That means diffusion takes place along with the dissolution. All the KMnO4 crystal first get dissolved and spread into the space of water and forms a beautiful pink color solution. Okay, now next is when acetone bottle is left open and bottle becomes empty. So what is happening when you have a bottle containing acetone liquid in it, and if you leave it open for some time, the bottle will become empty. That means all the acetone get vaporized. As you know, acetone is a volatile liquid. So here two processes are happening. First, evaporation and diffusion also. Evaporation means all the acetone liquid is getting vaporized and it is going into the space of air. So diffusion and evaporation both are happening here. Now settling, you can expect more than one process is happening in one case simultaneously. Okay, the settling of sand, when mixture of sand and water is left undisturbed. So what is happening when the sand is getting settled at the bottom of the vessel containing water in it? It means sedimentation process is happening. Simple process. Okay, then fine beam of light entering through a small hole in a dark room and will illuminate the dust particle in its path. So it is Tyndall effect. You can see here, if this is the beam of light which is just entering into the room through the hole on a wall. So this is a wall and there is a hole on the wall here, and when the beam of light is entering to this hole, so it is illuminating all the dust particles present in air in that room. So while entering into the room, and when it is making the path, the light is making the path, it also start illuminating the dust particle whatever is there in the air in the room. So this type of process is or phenomenon is called as what? Tyndall effect. Okay, now you have last question. The teacher instructed 3 students A, B and C respectively to prepare 50% solution of NaOH in mass by volume percentage. Okay. So students have to make what? 50% solution of NaOH in mass by volume percentage. Okay. So A student dissolved 50 gram of NaOH in 100 ml of water, while B dissolved 50 gram of NaOH in 100 gram of water, while C dissolved 50 gram of NaOH into water to make 100 ml. So students, see what did he do? He did not take first only 100 ml of water and start adding 50 gram of NaOH in it, but he took a small amount of water. In that he start adding little NaOH and then water, then again NaOH, and he added full 50 gram of NaOH in enough water to make full solution 100 ml. So NaOH plus water completely forms a solution 100 ml of solution. Okay. Now which of them has made the desired solution and why? So out of these 3 students, who has done the correct process or who has correctly made this 50% of solution of NaOH in mass by volume? So first we will see. So student C actually has done correctly. We will see how. So you know that mass by volume percentage can be written as mass of solute divided by mass of solution into 100. Okay, and mass of solution, how we'll calculate? We will calculate mass of solution by mass of solute plus mass of the solvent. Okay, so how we will get 50% of the solution? We will just calculate. If we take 50 gram of or 50 ml of solute in 100 gram or 100 ml of water, then you can just cut it. We will get 50 here. So 50% of NaOH solution we will get if we have solute 50 gram getting dissolved in mass of solution 100 ml. So mass of solution will be 100 ml. So C has actually have the mass of solution 100 ml, but A and B do not have. We will see how. So you know that student A has taken 50 gram of NaOH in 100 ml of water. So it is the mass of solute and it is the mass of the solvent. So we will add, we will get the mass of solution. So mass of solution will be more than 100 ml and we wanted mass of solution 100. So A has done wrong. Now we will see B. B student has added 50 gram of NaOH in 100 gram of water. That means still we will get how much? 150 gram of solution, whole solution, where we wanted mass of solution to be 100. So here we got 150 grams. So we have actually made 150 gram of solution. So that is also wrong. Now C has added how much? 50 gram of NaOH in enough water to make whole solution, full solution 100 ml. So he has full solution 100 ml. That is correct. And so he has correctly made 50% of NaOH solution in mass and volume percentage. Now I have to just tell you one more thing here. When you add 50 gram of NaOH in 100 ml of water, then how to calculate the mass of the solution? So here I have written mass of solution will be 50 gram. We have to first convert into the volume, that is ml. So 50 divided by 2.13 gram per ml, 50 gram by 2.13 gram per ml, we will get 50 by 2.13 ml. What is 2.13? 2.13 is the density of NaOH. So when we will mass by density, we will do mass of solute by the density of the solute. We will get the mass volume of the solute, that is in ml. Okay, and then we will add 100 ml of we will dissolve in 100 ml of water. So in this type of problem we will further solve also, don't worry. So that was about your NCERT questions. So on every Tuesday we will discuss some of the NCERT questions, NCERT based question of chapter 1 and 2, and on every Friday we will continue with our third chapter, that is atoms and molecules. Thank you.